The process of changing out a Westerbeke 30B diesel engine to a Mercury 25 horsepower gasoline engine on a Gemini 105 MC 2001 boat. I'll try to keep this as short as I can. First, I want to make sure I thank Brian and JP and the other people who've posted on the site, and many people who've done this before me who made it possible to do this. It took about 2 weeks to do it, mostly single-handed. It wasn't a planned operation. It was short notice. The idea was to get the boat functional as quickly as possible so that we did not miss a whole sailing season in Nova Scotia. All the work was done in the water. It took approximately 14 days, and then a few days afterwards, which might be explained later. So I hope this is helpful to anybody who wants to change out their Gemini power plant or something similar. The reason we decided to do this was that our Sillet drive leg started leaking oil. I was going to take it off and replace the oil seals, but in the process, the bracket which holds the drive leg cracked. And so realizing that we had a 20-year-old engine in there, which was running fine, but the process of fixing the Sillet drive would have taken many weeks, and we still would have had a 20-year-old engine. So we went ahead and decided to change out the engine. I'll try to hit all the steps I can in case you do this, or even if you need to instruct the boatyard how to do it. So once the decision was made, the first part involved getting the Sillet drive off, and you can see there's a few steps in the process: taking the drive off of the mount, taking the mount off of the boat, lifting the drive off, which I used my hammock, couch, whatever you want to call it, used the frame for that, which was custom made out of 1 inch Schedule 40 stainless steel pipe. There was plenty of strength for it to hold the Sillet drive, and later to hold the outboard to put it back on, to put it on originally. First off, don't underestimate the time it's going to take to select what engine you're going to use. There are options available. I ended up with a Mercury, partially because that's what was available locally in the time frame I wanted to do this in. It turned out to be probably as good as choice of any. We got a 20-inch shaft. A 25-inch shaft would have been preferable, but as far as I could tell, at least in Canada, you're not going to find a 25-inch shaft in stock unless somebody ordered it and canceled it. You pretty much have to get it from the factory. So what we did was we ordered a Bay Manufacturing 5-inch extension, which has not been put on yet. I'll save that for the fall. But selecting the engine, both in terms of time and labor, you don't only have to select it, you're going to have to go purchase it someplace, and then probably they're going to have to prep it. It only took 2 days in this case for them to prep the engine, which was great. You'll see that there's some pictures of taking measurements. I was not able to find any specifications for the engine, so before I went ahead and started assuming things and drilling holes and things, I hung the engine up in the shed and started to measure distances for various pieces of the puzzle. By the way, some people have gone with 15-horse motors, 20-horse motors. I wouldn't do anything less than a 25-horse motor. Plenty of power in it, but as you know, sometimes you need it, and that's when you want to have it. This turns out to be a 3-cylinder instead of a 2-cylinder. Very glad about the decision so far. This is the end of the season. It has power, it has reserve power. I'm very happy with the Mercury. Trying to cover all the steps here, and some of these things may seem minor, but there is the process of getting something that weighs close to 200 pounds to your location if you're doing it yourself, but in this case we did, so off the truck, hang it in the shed to take measurements. Then we needed to get it from the front yard to the backyard, down the ramp, down some steps, back down the ramp onto the float, and then onto the boat. I ended up buying this rolling cart from Canadian Tire. I think it was about $250 Canadian, supposed to handle 1,200 pounds. Certainly made the job possible and safe. So a significant part of the project was finding a way to mount the outboard motor to the transom of the Gemini where the Select drive was removed. A key component of this was a Panther Bracket. Again, a lot of research was involved, a lot of time was spent checking things out. Other people have used these Panther Brackets. It does seem to be more than adequate. There's some things we'll talk about a little bit later, but that's the bulk of the project, is getting the engine mounted to the boat, and there may be other ways to do it, but it turns out using this bracket, which cost me about $465 or $85 Canadian from Amazon, it worked out very well. One thing to keep in mind, you will not be able to open and close this bracket. It's got springs in it to make it possible to lift a heavy motor, so you pretty much have to take measurements. There's some pictures showing some holes drilled in the Panther bracket. That's because the bracket, when it comes out of the box, is about 2.5 inches higher than it needs to be for our purposes. So the idea was to slide this backboard, this plastic transom, down. It has some springs in it which use to lock the mechanism so it doesn't pop out of place on you. So the springs had to be drilled out and remounted, and everything had to be adjusted. And then also you'll see some pictures where you see at one point the bracket looks all curvy and so forth, but then it looks square. That's because I added a 1/2 inch piece of exterior plywood which was coated in epoxy to move the motor further away from the boat. The main reason for that is you want the motor to tilt up, and it needs, I forget how many inches it needed now, but that was part of taking the measurements. So you need to have the motor be able to tilt up and not bump into the back of the boat. So the key thing was getting this bracket modified and then getting the bracket to mount onto an aluminum plate. The aluminum plate, I think, was somewhere between 1/4 and 1/2 inch. It might have been a 1/2 inch, but I also used some aluminum stock, 1/2 inch by 2 inch by, I think, 18 inch aluminum stock, to also get that bracket moved out as far as it needed to be to let the motor tilt all the way up. It is a hydraulic tilt. That's part of what you're going to want to get on the motor to make it work for you, so you can get out of the water when you're sailing and just when you're not using the motor. Again, significant part of the project was mounting this Panther bracket onto an aluminum plate and then bolting that plate to the boat in the right place. Part of the reason for the plate is to distribute the load, but it also covers up all the holes. It covers up the original exhaust hole, covers up the hole where the Select drive went through. I used 1 inch by 2 inch by 18 inch aluminum bar stock behind the plate inside the boat to brace the bolts that were bolted through the transom. It is about 2 inches, 2.5 inches thick. Getting hardware is part of it. I probably spent a total of 2 days rounding up materials, maybe 4 days if I include the aluminum and so forth. If you live in the United States, this is probably all easier. In any case, here's some pictures showing the bracket out of the box, and then the bracket being slightly modified to lower that transom plate that's on the bracket, and then modify it so that the locking springs would still work. And then I added a piece of plywood on top to move it out from the boat 1/2 inch, and I also used the aluminum bars to move it out further. So you can see some pictures of that here. As mentioned before, if you're doing this yourself or with friends, if you're not hiring it out, don't underestimate the fact that your motor's going to weigh somewhere between 160 and 200 pounds. May seem like a simple thing, but you're not going to manhandle the thing onto the boat, even if it's not in the water. Probably best to do this out of the water, but due to circumstances, we did it in the water. It worked out okay. Used a dinghy for part of it, and then my neighbor was putting in a can dock, a modular dock system, so he lent me some of the sections, and we used that in the later stages to mount the motor. We needed to slide the motor off the cart onto the dock, from the dock to the modular dock system, put some pieces of plywood down, slid it over, and then again use the frame for the hammock or the sling to jack up the motor, or pulley up the motor, use a block and tackle, and the redundant block and tackle also ran it to a winch to make sure we didn't lose it. As mentioned, I did this, primarily one person did this. Fortunately, had helpful neighbors, and interestingly, the 3 or 4 times I needed help, they would just sort of show up and say, "Do you need help?" So that worked out pretty well. Another part to consider is replacing the control unit, the throttle and gear shifter lever. Might seem like an incidental thing, probably took me 10 to 16 hours after all was said and done. And again, a lot of this involves sourcing parts. In Canada, it's not as easy as you may be used to in the United States, but still you have to find the right parts. That takes time. Then you have to either get them shipped or you have to go get them. All in all, 2 weeks, maybe 16 days was total. Back to changing out the control unit, the shifter and throttle. In this case, it was kind of a generic throttle unit, and then it had to be fitted to the Mercury motor. The documentation for this throttle unit was terrible, and so was the documentation for how to hook it to the Mercury motor. But we got it sorted out, but took a lot longer than I expected. In terms of routing the cables, I first did a quick check of routing them the way the original cables were routed, but that wasn't going to happen very easily. So I routed it through the starboard berth, and that involved using a vibrating cutter to cut things out a little bit further. And I still need to do some finishing in the fall, but it didn't go too badly. It did take about 2 days, and I used 24 feet of cable. Probably could have got by with 22 feet, but didn't know that at the time. I did reuse one of the fuel tanks. There's a diesel generator in the boat, so I left one tank in. So for this season anyway, we used the existing diesel tank. I just capped off the return hose, the diesel return hose. I did separate the vents, got a new vent fitting, and blocked off the fitting. The original tanks share a vent. This is an air vent, not the return fuel line. I blocked off the one side and reused the hose to vent the tank, which would now be a gas tank. I replaced the feeder hose. I reused my Raycor MA500 filter unit. I was told by the Canadian distributor for Raycor that this is completely okay to do, as long as, please note, you do not put any electrical components in it, or if you have them in it, you have to take them out. In the diesel unit, you can have a moisture sensor, and you can also even have a heater. You cannot use any of that with gasoline. You cannot use any electrical components in it with gasoline, but otherwise, if you're using a Raycor 500 MA filter unit, you can reuse it. I cleaned the tank simply by pouring a half a gallon of gas in, pumping it out, pouring a half a gallon of gas in, pumping it out until the color of the gasoline, the fresh gasoline, was the same as fresh gasoline. It was no longer had any diesel in it. It worked fine. There's just a quick picture of the Bay manufacturing extension and the pieces that come with it. First, we took the boat out for a ride with the Westerbeke still in it. Wanted to see how it ran and so forth. It ran okay. We didn't have a deflector plate on it, which I later added, which was just an aluminum plate, which you'll see a picture of it later. It did take about 2 days to get the diesel out. Again, working primarily alone. Got a little help from the neighbor at the final stage of taking it off the boat. But it was a project in itself. I was lucky. There were no frozen bolts. It all came out, but still took a lot of time. And the engine's heavy. Supposedly it weighs somewhere around 275 pounds or something, but I think it weighs a lot more than that. As you'll see, I still need to trim out the inside of the boat where the cables ran through, the electric cable and the control cables. Also, I'll need to trim out the where the controller unit goes. Here again, we wanted to use the boat for the summer and not spend all summer working on it. The deflector plate is just made of a piece of aluminum, comes from underneath the boat and slants down to connect to where the bottom of the motor frame mounts. It keeps the water from backing up against the motor. Makes a tremendous difference. You saw a picture of the bay manufacturing extension, which will go on later. I used the control system that JP recommended. I hope I got his initials right. It's just a block and tackle system, but modified his a little bit. There's 3 or 4 pictures of how I basically just release the line with a regular cleat. I'd like to use a clam cleat in there, but when the motor goes up, in order to steer the boat while you're under sail, you have to loosen those lines. If you get to that point, it'll be obvious. I did put in a tachometer. Took a long time to figure out how to do it because Mercury is not very helpful. They just want to sell you services. In any case, it turns out that there's a cable, part of the cable set, and instead of paying $100 for an adapter, which made a plug turn into 7 blank wires, I just cut the other plug off and I had the 7 blank wires. And it turns out the gray one is the wire for the tack, and it's pretty clear. You could hook it up according to the tack instructions. And there's some pictures of the boat under sail. I can do about 6 knots with it without being at full power in reasonable seas. I usually go about 5 knots and run the thing at about 3/4 speed. So far, it's been fantastic. Very reduced noise, very easy to put it up and down when you go from sail to motor. Overall, we're completely happy with it. Total price was under $10,000 Canadian, which is probably somewhere around $7,000, $7,500 US. This was all done in the summer of 2022. And again, thanks to everybody who posted on the Gemini forum. Thanks for the people who are hosting that forum and managing it. It's a great resource. I can be found on the forum if you have any questions. Under Repower would be the tag. There's a lot of information there. If you take this on, good luck. It's doable, and you won't regret it probably.